Okay, guys, I've leveled up. So I have the digital copy of your textbooks here, and I think I like this a whole lot better. So today's lesson is angle relationships. Let's look at today's goals. Today we need to, one, calculate angle measures using the characteristics of complementary and supplementary angles. Those are two terms that we are going to look at today, and they are very, very important to us, okay? Next, we're going to calculate angle measures using the characteristics of perpendicular lines. That is another term that's going to be very useful. And we also need to demonstrate understanding of what can and cannot be assumed from a diagram. All right. All right, so in your textbooks here, you have this diagram here giving you the two terms that we talked about before. We have complementary angles and supplementary angles. We're going to explore those two types of angle pairs and talk about what they mean. So complementary angles, those are any two angles with measures that have a sum of 90. Okay, so again, the term sum, that means when you add things together. So if I've got two different angles, as long as I add them together and they equal 90, those will be considered complementary. And so they've given us an example below. We have two separate angles. This one's measure is 30, this one's measure is 60, and when you add those together, you do get 90 degrees, so those would be considered complementary angles. If you scroll down a bit, there's another example there. Notice it's a bit different. So this example here has two angles and they're connected. Okay, that's still fine. Again, as long as you add the values together and they equal 90, yes, they are considered complementary. And so a way that I remember what complementary angles are, let's write this down here to the side. So somewhere in your textbook, please write this down. Okay. It is always the right thing to do to give someone a compliment. So it's always right to compliment someone. Right? That's nice. It's nice to give your friend a compliment, like, hey, I like your outfit today. Okay, that's the right thing to do. And remember, 90-degree angles are also called right angles. So that's a little way to remember. Now the next type of angle that we have, they are called supplementary angles. So supplementary angles, they are two angles with measures that have a sum of 180. Okay, so if we look here again, 110 plus 70, that does give us that value of 180. So yes, these would be considered supplementary angles. If we scroll down to that other example, okay, so here these two angles, they are connected. They form a line. And they also, if you add these together, they give you that 180 degrees, okay? A trick here, guys, anytime two angles meet together like this to form that straight line at the bottom, they will always be supplementary. Because if we think back to our previous lesson, right, lines, every line ever, will always equal 180 degrees. Therefore, lines are always supplementary angles. Okay. And that's kind of what they're talking about here in the think about it section. So it says a linear pair is blank supplementary. So a linear pair, aka lines, are always supplementary, while two supplementary angles, they are sometimes a linear pair. Okay, what that means is the term supplementary, that just means, again, if I add them together, they will equal 180 degrees. Okay, if we look back at this example here, those two angles are not connected and they don't form a line. So those are not a linear pair. I might add that note here in this box. These are not a linear pair. However, this next set is, okay? These are a linear pair. So that's the difference there. Linear pairs must be connected. They must form a line. But both of these examples are examples of supplementary angles. All right, let's turn the page and go to example 1. So this is an example showing how we can use the definitions of complementary and supplementary to solve problems, okay? So they have step-by-step laid out how to solve the problem, but to me, I don't really have much room to work with. So what I'm going to do, let's see, maybe I can paint. Okay, yes. I'm going to give me some space to work with here. Let's see. There we go. But feel free in your textbook just to fill in the blanks as I solve. I'm going to solve it just like they did, but I'm just going to give me some room to work and to also take notes. Okay, that's a lot better. All right. Okay, so here it says, find the measure of two complementary angles if the measure of the larger is 5 more than 4 times the measure of the smaller angle, okay? So for most people, just reading that gave you a stroke, right? It's a lot of information, there's a lot of words, but let's break it down, okay? So the first thing that I know, I have 2 complementary angles. Now, if we think back to what complementary means, right? That means when I add 2 angles together, they should equal 90 degrees. It's always right to give a complement. So I'm going to lay that out here. I've got one angle plus another angle. When I add those, it should equal 90 degrees because they told me they were complementary, okay? Now, let's move on. It says the measure of the larger angle is 5 more than 4 times the measure of the smaller, okay? So what's happening here is we have to create a representation of both the larger angle and the smaller angle, okay? The smaller angle is what's being used to compare the larger angle to, right? It's saying the larger is 5 more than 4 times the smaller. We don't know what the smaller angle is. So I'm going to go ahead and call that x. We don't know what it is. Anytime we don't know something in math, we're going to assign a variable, okay? So this is the smaller angle. Now, we can kind of think about how we might represent the larger angle. If the smaller is x, the larger is 5 more than 4 times the smaller, okay? 5 more. That word more, that's going to mean addition. So a plus 5 is going to have to be somewhere in that expression, okay? 4 times the measure of the smaller. So 4 times, that would be multiplication. So it's 4 times x. So 4x plus 5 is the representation of that larger angle. And so now we have a complete equation. We can use this to solve for x. So we'll do that first. All right, so we have our equation. We can combine like terms first. I see an x and a 4x. That's going to combine and give me 5x. I have a positive 5, so I can move that by subtracting it from both sides. So 5x is equal to 85. And I'm trying to get x by itself, so I'm then going to divide by 5 on both sides. And so x should be 17. All right, now on to step 2. So we found the value for x. We found the missing puzzle piece. But we now have to find the actual measures of the two angles. Okay? And so remember, the way to do that, if you ever have to find a measure, you have to take your x that you found and you have to plug it back in. So the easiest one, we already know the smaller angle. Okay? The smaller angle, we used x to represent it. Well, we already know what x is, right? X is 17. So the smaller angle is 17 degrees. Okay? Another side note, guys. So anytime you see, anytime you see an italic M, just like this in geometry. Well, that didn't work either, whatever. An italic M, that means measure. Okay, so just FYI from now on, if you see that in maybe a quiz or a test in the future, an italic M means measure. So we have to find the measure of the larger angle. The larger angle is represented by 4x plus 5, and we know x is 17, so we're going to take that, plug it in. So 4 by 17 plus 5 is going to give us our measure of that angle. So 4 by 17 is 68. 68 plus 5 is 73 degrees. Okay. So now, what if I was unsure of my answer? What if I want to really make sure that I have the correct measurements? Well, if we go back, they're complementary angles, so we know when we add them, they should equal 90. So let's try that. 17 plus 73. Double check and see if it equals 90 degrees, which it does. But that's a good way to double check yourself. All right, so that being said, guys, go ahead and try the check. See if you can solve it on your own before I show you the answer. So you might want to pause this video right now, but you're still using the same rules, okay? One thing I want you to notice here, before we were talking about adding two numbers together, here they talk about difference. And think back to algebra, okay? The term difference, that means subtraction. So instead of adding two numbers, you are actually subtracting. So, like I said, go ahead and pause the video, try it on your own. All right. So, it says the difference between the measure of two supplementary angles. Okay, so differences here, we're dealing with subtraction. We're also dealing with supplementary angles. And before we learned that those add up to 180 degrees. The difference is 18 degrees. And so we have to find the measure of both the smaller and the larger angle, okay? So we'll kind of set it up similarly. So we've got two angles, but in this case we're subtracting because of it being the difference. And they are supplementary, so I know in the end, when I add them together, they should equal 180, but it tells us the difference is 18. So we're going to put 18 here out on the end, but we're still going to use the fact that they're supplementary to figure out, okay, how do I represent each of these two angles here? So I don't know what the smaller angle is, so I'll call that X. Always start out that way. Now let's think about how we might represent the other angle, okay? And I'm sorry, my bad. I said that this was the smaller. We don't know that yet. Hold that thought, okay? So this is just some angle we don't know. We'll call it X. Now let's think about how we'll represent the other angle. We were told they were supplementary, right? So if I took x away from 180, it should give me that other angle, because the opposite of that would be addition. So because of that, I can represent this other angle as 180 take away x. And so now I have an equation I can work with, and I can solve for the value of x first. So let's do that. So over to the side here, our equation is x minus 180 minus x equals 18. 18, not 180. So whenever that negative sign is applied, we're left with minus 180, right? And then negative times negative becomes positive, so plus x equals 18. Now if we look here, we have an x and another x, so that would be 2x. I want to move that 180 over, and it's a negative 180, so the opposite operation would be to add 180 to both sides. And so now I'm down to 2x equals 198. I'm going to divide by 2 on both sides to cancel that out. And so x is equal to 99. And so x equals 99. That represents one of the angles that we need, because one of those angles is just x. So we know one of them is 99 degrees. Now we want to figure out the measure of the other angle. Well, we said that was represented by 180 minus x. So 180 minus 99 gives us a measure of 81 degrees. So we have one angle equal to 99, one angle equal to 81. Again, if you wanted to double check, add them together. Make sure they equal 108 because they are supplementary. If that happens, you've done something right. Okay, our next thing that we're going to learn is that term got tongue-tied there. Perpendicularity, or perpendicular lines, okay? So it says lines, segments, or rays that intersect at right angles. Those are considered perpendicular lines. So if I have a perfectly vertical line and a perfectly horizontal line, those two lines will meet at 90 degrees, and we call those perpendicular lines. Okay, so let's turn to the next page and see some examples with that. So on the next page, we have the following diagram. It says that perpendicular lines intersect to form 4 right angles. If we look at this picture, we only see one 90-degree symbol. But again, let's go back to our previous lesson. We learned about vertical angles. Vertical angles are always equal. So vertical angles are equal. So if I know that angle AEB is 90, then I also know its vertical angle will also be 90. So DEC is also 90 degrees. Also, we learned about linear pairs. 2 angles that come together to form a line, they will always equal 180. So if I know this is 90, let's look at that top half there. So this line here, we're going to focus on this top angle. Okay, we know 1/2 of that line is 90 degrees. So what should the other half be? Well, 180 take away 90 is another 90. Okay, and because that angle here is 90 degrees, we know its vertical angle will also be 90 degrees. So that's why. Anytime, guys, you have a diagram like this and one angle is marked as 90, go ahead and assume all 4 are 90 degrees as well. Okay. Over to the side here, a new symbol. If you see an upside down T, that means perpendicular. So this statement here, this actually says line AC is perpendicular, and I'll just abbreviate, to line DB. All right, let's look at example 2. Again, guys, I went ahead and blocked off all that information that they have given you in your textbook. So as I solve this, just follow along, fill in the blanks. But we have the following problem. It says the tangram is a puzzle consisting of 7 flat shapes called tans, which are put together to form a shape. Find the value of x and y. Find the value of x and y such that AD and EC in the tangram are perpendicular. So we know whenever perpendicular lines are formed, they create 90 degrees. Okay, so step 1, let's go ahead and try to solve for y. And if we look at our diagram, we have to find where y is. It's right here in that angle ABC. So 3y plus 15, if I want to solve for y, I have to set that expression equal to something, okay? And they went ahead and told us that the 2 lines here are perpendicular lines. So I know that where those 2 lines meet, it's going to form a 90-degree angle. So we're going to set 3y plus 15 equal to 90. And then we'll solve. So if we take away 15 from both sides, that is going to be 3y 75. Oops. And then I want to divide by 3 on both sides to get y by itself. So y is equal to 75 divided by 3 is 25. So step 1, done. I'll do step 2 over to the right-hand side. I'll do it in blue. We're going to solve for x. So same thing again, guys. We're setting something equal to 90. If you notice, the x's are split in half. We've got a 7x plus 10 and 8x plus 5. When you put those together, that gives you your 90 degrees. So we want to make sure to add them, okay? So 7x plus 10 plus your 8x plus 5. All that together is going to give you 90 degrees, okay? So then we can combine like terms. Okay, combining like terms. So we've got a 7x and an 8x, so that's going to be 15x. We've got a 10 and a 5, so that's going to be 15. If we take away 15 from both sides, that's going to be 15x is equal to 75. And then we're going to divide by 15. So 75 divided by 15 is 5. Okay, on to the next page. Try the check on your own. Pause this video. It's very similar, guys. Make sure to set things equal to 90 and solve. We'll see how you do. Okay, it's a very similar problem. So here we've got 2 lines. They are perpendicular, okay? So because of that, we can set all the expressions equal to 90, okay? So for y, our 4y minus 2 is equal to 90, and that gave us y equals 23. For x's, just make sure that you add the little parts together. So 5x plus 6 plus 2x equals 90, and in the end, x should equal 12. And so the last bit here for our lesson talks about what can and cannot be assumed from a diagram. Rule of thumb, guys, if you do not have a symbol Or if someone or somewhere in a problem does not tell you specifically, like things are equal or there's a certain relationship between certain shapes or angles or lines, do not assume anything. So when you are looking at a diagram, do not assume anything unless, one, you have the markings given to you, or two, the word problem actually states it. So again, one thing that I kind of relate it to, think back to whenever we had that right triangle problem, okay? If I'm just given this shape right here, I cannot assume it's a right triangle. Now, if they gave me that triangle and put a little box in the corner, yes, I have the marking, so I can assume it is a right triangle. So never assume. So we're going to skip over to the very, very last page, page 80, and we're going to go through here and check what statements can or cannot be assumed. So the first statement says angle KHJ, so KHJ, and angle GHM are complementary angles. So can we assume that? Is there anything they're telling us when we add them together, they will equal 90 degrees? Well, no, there's not. The only markings that we have are congruence marks. I know that angle KHJ and GHM are congruent. They are the same. But do we necessarily know if we add them, they will equal 90? No, we do not. Okay, so statement A cannot be assumed. Now for statement B. B says GHK, so this entire angle here, and JHK, this angle here, are a linear pair. So it's asking when they come together, do they form a line? Well, if we look here, they in fact do, and we can even connect those angles that way. So that is a true statement that can be assumed. Okay. Our next statement says ray HL, so HL, is perpendicular to HJ. So can that be assumed? Again, if we have perpendicular lines, they should equal 90 degrees at their intersection. So a suggestion I would do, I would go from one line to the other, make that connection, and look at their intersection right here. Okay, I'm going to draw that a little bit more in a more clear way. So we've got line right HL and HJ. So from here to here, is there anything in the shaded region telling us that they will equal 90 degrees? No, there is not. So this statement cannot be assumed. Now, what some people might think, they might see that little 90-degree symbol there and think, oh, well, it's right next to the other angle, so the other one must be 90. But keep in mind, that little section there equals 90, and just that piece there does not form a line with the shaded angle, okay? The 90-degree angle here and this little piece here will form that line to give you that linear pair. So just be careful of that. I think they might have done that on purpose to kind of trip you up. Okay. Let's look at statement D. So angle GHM and angle MHK. Let's do a different color. MHK. They are adjacent angles. Well, adjacent just means they're side by side, right next to each other. So yeah, we can definitely assume that. Now for our last statement. It says that ray HL is perpendicular to HM. So this is kind of what I was meaning before. Look at the two lines, connect the lines to identify the angle, and then look inside the angle there, okay? Look inside there in the shaded region. Is there anything there telling us that that is a 90-degree angle? Well, yeah, there is. There's a 90-degree symbol. So we can assume that statement. So the only two answers we cannot assume are statement A and statement C. Okay. Guys, please make sure that you have paid attention and included things in your notes. We will be taking a quiz as usual, and let me know if you have any questions.